Welcome to this explainer. Today, we're doing something a little bit different. We're leaving the warm, familiar light of our sun completely behind, and we're taking a journey straight out into the absolute zero of the void. When we look up at the night sky, we're practically trained to focus on those bright points of light. But today, we're going to explore one of the most fascinating and honestly kind of haunting mysteries hiding in the darkness right between those stars. Planets that wander through space completely alone. So think about this for a second. When we picture a solar system, our minds naturally go to what we know, right? We think of planets as these warm, dynamic worlds locked into predictable orbits, just constantly bathed in light and solar wind. The star is everything. It provides the gravity, the energy, the anchor, but it brings up a huge fundamental question. What actually happens when a planet is stripped of all that? What is the physical reality of a world existing entirely in the cold, pitch-black expanse of interstellar space? Because without that orbital tether, there's no looping path. Without a star, there's no solar winds sparking auroras in the sky. There's literally just a silent, endless drift, dictated entirely by the immense collective gravity of the Milky Way galaxy. It basically becomes a ghost ship, out there in a cosmic ocean. All right, let's get into it. Section 1. Meet the rogue planets, wandering the interstellar void. Okay, so a rogue planet is officially defined as a world that roams interstellar space, completely independent of any star. But to really wrap our heads around them, we have to look at the mechanics of exactly how they end up wandering space in the first place. You see, most of these planets aren't actually born out in the void. They're born in those chaotic, super-crowded disks of gas and dust around young stars. And during the early days of a solar system, planetary orbits can be wildly unstable. So when massive gas giants pass just a little too close to one another, they engage in this incredibly high-stakes game of gravitational billiards. Those immense gravitational forces act like a giant cosmic slingshot, accelerating a smaller world to such unbelievable speeds that it just violently breaks free from its star's grip forever. And once it's ejected, it's doomed to wander the interstellar medium in this massive, untethered trajectory. It's such a stark contrast. On one hand, you have standard stellar system planets locked in this continuous, elliptical loop, right? Securely held on a tight gravitational leash by giant balls of burning gas. But on the other hand, these rogue anomalies chart an entirely different path. They wander completely independently. Their courses are only gently bent by the really slow, sweeping gravitational currents of the galactic core, or vast molecular clouds, or passing star clusters. A rogue planet might travel for literally billions of years, crossing thousands of light years across the galactic disk without ever feeling the warmth of a star again. Moving right along to Section 2, From Giants to Earth-Sized, an Evolving Understanding. Now, our understanding of these wanderers has actually changed a lot. In previous decades, our discoveries were pretty heavily biased by our technological limits. Initially, astronomers could really only spot incredibly massive rogue planets. We're talking worlds the size of Jupiter, or even larger brown dwarfs, because their massive size made them just a little bit easier to detect against the dark backdrop of space. But today, the science is revealing a completely different reality. Much smaller wanderers exist out there in the dark. Going from just spotting massive anomalies to realizing the void is actually teeming with smaller worlds is a monumental leap in astrophysics. And as we'll see, it perfectly sets the stage for a highly anticipated space mission launching in 2027 to hunt them down aggressively. For a long time, it was super easy to just imagine massive gas giants being the main victims of those early gravitational slingshots we talked about. But we now know for a fact that much smaller, rocky rogue planets are drifting out there too. And when you stop and think about the physics of a rocky world wandering deep space, it's just staggering. I mean, with no sun to warm it, the surface of an Earth-sized rogue planet would be permanently locked in the deep freeze of absolute zero. Any oceans would turn into solid, miles-thick ice, and the atmosphere itself would probably just freeze and collapse right onto the ground. But here's the crazy part. Insulated beneath that thick shell of ice, the planet could actually retain its internal geothermal heat from its violent formation. That means it could keep subsurface oceans warm and liquid. It's literally an entirely hidden, dynamic world just blindly drifting through the galaxy. Which brings us to Section 3, the Milky Way's nomads, a massive twist in scale. So there was this absolutely groundbreaking joint study from researchers at NASA and Osaka University in Japan. They wanted to map out exactly how many of these nomads are hiding right here in our own Milky Way. But as you can imagine, investigating the abundance of completely dark objects in a pitch-black void is a staggering technical challenge. So how they do it? They used a phenomenon called gravitational microlensing. Basically, when a dark rogue planet drifts perfectly in front of a distant background star, the wandering planet's gravity physically bends the fabric of space-time. It magnifies that distant starlight like a giant cosmic lens for just a fleeting moment. By analyzing these temporary spikes in light, the researchers rigorously reevaluated just how common standard stellar system planets actually are, compared to these unbound wanderers. And the results? They present a truly shocking suggestion. Rogue planets might actually be the majority in our galaxy. There could be billions, possibly even trillions, more planets wandering the dark, entirely independent of any star, than there are planets orbiting suns. I mean, this completely flips our whole understanding of the cosmos upside down. Think about it. For every single star you see burning brightly in the night sky, there might be several unseen, nomadic worlds just drifting silently in the vast, empty spaces between them. In the grand architecture of the Milky Way, the solar system model that we call home might actually be the exception, while these wanders in the dark are the rule. Okay, let's look at Section 4, Roman Space Telescope's mission, Hunting the Nomads. The entire future of this field really hinges on one incredible piece of technology, NASA's Nancy Grace Roman Space Telescope, which is scheduled to launch into the cosmos in 2027. Its capabilities are literally tailor-made for this exact pursuit, because rogue planets don't emit their own light, and they just move independently through the interstellar medium. Conventional telescopes looking for planetary transits across a host star are completely useless. The Roman telescope, though, it's designed with this massive field of view. It's going to stare at hundreds of millions of stars simultaneously toward the center of the galaxy, just waiting patiently to catch those tiny momentary warps in space-time, those microlensing events we talked about, created specifically by nomads wandering right across our line of sight. And the expectations for this mission represent a massive leap in scale. According to NASA, this remarkably powerful new observatory won't just find a few scattered anomalies out there. They think it could actively catalog a hidden population of roughly 400 rogue planets, with masses remarkably similar to our own Earth. We're talking about definitively tracking down worlds almost identical in size and mass to our own. It's going to pull back the curtain on an entirely new demographic of planets that have just been silently passing us by for billions of years. So the game plan here isn't just a simple checklist. It is a unified scientific campaign to map the unmappable. Step 1, of course, begins with launching this cutting-edge observatory in 2027, getting it high up above the interference of Earth's atmosphere. Then, researchers are going to turn its wide-field gaze deeply into the darkest interstellar spaces of the Milky Way, capturing the faintest distortions of gravity over time. And ultimately, this campaign will pull the gravitational signatures of hundreds of these Earth-mass nomads straight out of the darkness and into the light of human understanding, finally giving us our very first true census of the void. Which leaves us with a truly chilling and honestly endlessly fascinating question to end this explainer on. If these recent studies are right, and our galaxy is indeed filled with more lonely, roaming planets than the orbiting ones we're so familiar with, well, just how close might the nearest wandering Earth be right now? Could an unseen, untethered world be quietly wandering through the cold void right at the very edges of our own Oort cloud? It's a vast, dark universe out there, and we are only just beginning to map the wanderers hiding in the shadows.